Okay, welcome back everyone. Okay, so this is the last part for my lecture, which is on the topic of evaporation. Okay, and to recall a bit of the previous topics that we have learned. Okay, we have learned on this part precipitation. Okay, on how to measure and what kind of precipitation that we have. Okay, and also how to measure infiltration. Okay, and for this part, it's going to be on these processes. Okay, which involve evaporation and also evapotranspiration. Okay, and usually there are several factors that affect those two processes. Okay, and a few of it is actually what type of vegetation that is involved. Okay, and what kind of water body and what is the quality of the water lah, of course, and also the weather conditions. Okay, and this is supposed to be a pre-class discussion that we should be doing in the class. Okay, but since you already did your project, okay, so by this time you would have understand, okay, what will happen, okay, pre-development and in post-development. Okay, what happens to these processes, okay, when there are developments in the area, okay, to this evaporation or evapotranspiration. Okay, what happened to the volume of runoff, okay, and also what happens to the volume of recharge. Okay, and if you are to go through this a bit, okay, so pre-development, okay, there are lots of greeneries, okay, and still less impermeable surfaces. Okay, so we are expecting a lot of recharge, okay, and less runoff, okay, and a lot of evapotranspiration since there are let me use my laser pointer. Okay, since there are a lot of trees still, okay, so there are a lot, the quantity of these processes is a lot compared to runoff. Okay, but when there are more impermeable surfaces, when there is development, okay, we are expecting a big change in the volume of runoff compared to the volume of recharge and evaporation. Okay, recharge is going to be less and less, okay, with the increase of impermeable surfaces. Okay, and with 10% or greater impervious cover is actually enough to impact the stream channels. Okay, the volume of water that flows directly into streams. Okay, and you may pause this lecture first, okay, when you reach this slide, okay, and you watch the video that I uploaded in the e-learn. Okay, you may go to e-learn. Okay, let's try that. Okay, when you go to e-learn, okay, so you can watch this video, okay, when you reach that slide just now. Okay, so now going back to this slide. Okay, so when there is urbanization, okay, we are expecting more runoff, okay, compared to the amount of infiltration and also evapotranspiration. Okay, that affects the processes, the amount of impervious surface. Okay, so it is important to, when you design your cities, okay, you need to also consider where, if it rains, okay, where this water will flow to. Okay, what should you do to minimize the flooding that is caused by this increased volume of runoff. Okay, you should consider that. Okay, so now going back into evaporation. Okay, it is actually a process where the liquid change to the gaseous state at the free surface below the boiling point through the transfer of heat energy. So that is the process lah. Okay, and usually the rate of evaporation, it depends on a few factors. Okay, so these are the factors. Okay, what is the vapor pressure at water surface and air above, and what is the air and water temperature, what is the wind speed, what is the atmospheric pressure, and the quality of water is also important, and the size of the water body involved. Okay, so those are the factors that affect the evaporation rate lah. Okay, and since we need to know how to actually estimate or measure evaporation, okay, and for that purpose, okay, you also need to know this term evapotranspiration. where this process involve vegetation, transpiration from vegetation. Okay, usually this is more significant, okay, in terms of the volume of water lah. Okay, and this portion of precipitation that is not available as surface runoff is what we call as loss. Okay, and then there's also this effect of vapor pressure on this evaporation. Okay, and usually the rate of evaporation is proportional to the difference between the saturation vapor pressure and the water temperature, which is denoted by EW, and the actual vapor pressure, which is denoted by EA, and it can be expressed like this. Okay, you can estimate the rate of evaporation by having these two terms. Okay, and where you also need the C, which is a constant for the type of water body that is involved. Okay, usually we can use 15 for small or shallow pools and 11 for large deep reservoir. Okay, so this is in general how you can estimate the rate of evaporation from the difference of vapor pressure lah. Okay, and then this relationship is called as Dalton's law of evaporation. Okay, where in this case, okay, when the EW, which is the saturation vapor pressure, is the same as the actual vapor pressure, okay, the evaporation will continue. Okay, and then when the saturation vapor pressure is bigger, okay, than the actual vapor pressure, okay, there will be condensation. Okay, and then there's also another term that you need to know, which is specific humidity. Okay, at temperature at dew point, which is denoted by this QV. So this is the formula for that. Okay, and that involves the actual vapor pressure lah in the calculation, and also the air pressure. And we denote this actual vapor pressure over the saturation vapor pressure as relative humidity. Okay, and then these are the explanation lah for the factors that affect the evaporation. Again, the temperature. Okay, we expect more evaporation will occur when the water increases and when the temperature increases. Okay, and then of course there's the effect of wind. Okay, the higher the wind speed, okay, the higher the evaporation rate. Okay, and there's also this critical wind speed. Actually it's a function of the size of water surface. Okay, and then for large water bodies, high speed turbulent winds are needed to cause maximum rate of evaporation. And there's also the effect of atmospheric pressure. Okay, where there is a decrease in barometric pressure when you go higher in altitudes. Okay, we are expecting more evaporation to occur. Okay, and of course there is also the effect of water quality. Okay, when the clearer the water, the higher the evaporation rate. So when there is solute, or like when the water is turbid, okay, the evaporation is expected to be less, okay, compared to a clearer water. Okay, and for seawater, okay, since there is saline, okay, in the water, okay, it is expected to be 2 to 3% less compared to freshwater evaporation. Okay, and then there's also the effect of water body size. Okay, so deep water bodies would have more heat storage than shallow ones. Okay, so that also affects this one lah. Okay, when the bigger the water body, it stores more energy. Okay, so that is on the effect of size water body. Okay, and then why is it important for us to estimate this evaporation? Okay, because it involves with usually with planning and operation of reservoir and irrigation system. Okay, especially in arid zones. Okay, evaporation is important, okay, to conserve the scarcity of water resources. Okay, so maybe you can also pause this video at this time. Okay, you can search in the YouTube. Okay, there's a video in I think in US. Okay, it's on about people throwing black balls in the lakes, okay, to reduce evaporation, and also to reduce the bromine content in the lake or something like that. Okay, you can explore more on that. Okay, that actually involves this part lah, on the planning part. Okay, to store the water in the lake, okay, to prevent it from evaporating too much. Okay, going on to the next slide. Okay, and how do we conduct this evaporation estimation? Okay, so in this lecture, there are three methods that you can use to do the estimation. Okay, first, by using evaporimeter. Okay, so it's a instrument lah. It's a few instruments that you can use to do so. Okay, and then you can also use empirical evaporation equations. Okay, and then there's also analytical methods. Okay, and then to do so, the meteorological data such as humidity, wind movement, air and water temperature, and precipitation needs to also be noted lah with the evaporation measurement. Okay, and the first one, evaporimeters. Okay, so basically it's actually a water containing pans which are exposed to the atmosphere, and the loss of water by the evaporation are measured regularly. Okay, in those pans. Okay, and there are many types of evaporimeters. Okay, and the most common ones are these three. Okay, the first one is Class A evaporation pan, and the second one is Colorado sunken pan, and the third one is this US Geological Survey floating pan. Okay, and we go to the first one, this Class A evaporation pan. Okay, so basically it's a metal pan. Okay, galvanized unpainted galvanized iron pan that is located, okay, near a water body, and placed on a support, wooden support, okay, to allow air to also flow underneath this pan. Okay, and you just measure how much the water decrease over time. Okay, to estimate the evaporation. Okay, there's a hook here, measure drop in depth with the hook gauge. Okay, in the stilling well. So this is the stilling well. Okay, so you measure how much the water drops over time lah for this one. Okay, and when the water you need to add more water. Okay, if you want to continue measuring the evaporation. Okay, so if we look here, okay, so it needs to sit here to allow also the air to circulate underneath the pan. Okay, and then the second one, we have this Colorado sunken pan. Okay, so just by the name, you know that it needs to be sunk and dig into and like you have to dig the soil and bury it in the soil. Okay, so that the aerodynamic are similar to those of a lake. Okay, and the disadvantages of this is because it's sunken. Okay, so it is more difficult to detect leaks. Okay, and it's more expensive to install. Okay, and you need to have extra care so that the surrounding area are free from any tall grass, dust, and etc. lah, so that it still represents how a lake behaves. Okay. Okay, and then the next one is this one, this US Geological Survey floating pan. Okay, so just from the name, you know that it needs to be floated, okay, in the lake lah, on top of the lake. Okay, and it is actually a square pan. Okay, it is also a metal pan. Okay, and then so based from this figure, okay, you can see that it is floated on top on the lake. Okay, and usually it is also installed with a ray gauge. Okay, and okay, if you look here, okay, for this pan, it needs to have this bird guards. Okay, so to prevent birds from sitting there and doing their things lah, or whether drinking the water or doing other things in there. Okay, so that can causes errors, okay, in the reading for that. Okay, since it is floated, okay, it is actually this pan simulate the characteristic of a large water body more compared to the other two. Okay, but the maintenance is going to cost higher. Okay, and it's difficult to perform the measurement since you have to you have to go to that pen in the middle of the lake to get the measurement, unless there are automatic gauge to do so. Okay. Okay, so when talking about evaporation pans, okay, it is not the exact model of a large reservoir or lake. Okay, so it has some drawbacks to it. Okay, because they differ in heat storing and heat transfer. Okay, from the sides and bottom. Okay, because obviously the pans are from metal. Okay, and the evaporation pan the evaporation from pan, it depends to a certain extent on its size. Okay, and the height of the rim in the evaporation pan can affect the wind action over the surface. Okay, and it can also cast shadow of variable magnitude over the water surface. Okay, which also affects the evaporation. And then the heat transfer characteristic of the pan material is different from that of a reservoir. Okay, so thus, okay, the value that is collected from the pan, okay, needs to be corrected using a coefficient. Okay, so you need to have this coefficient so to get a better estimation of the evaporation value. Okay, so this pan coefficient Cp is actually a value of lake evaporation over the pan evaporation. Okay, and the value that is used for different pans are as stated below lah. Okay, so for class A pan, an average value of 0.7 can be used. Okay, so it's a matter of you timing this with the pan evaporation that you get to obtain this lake evaporation. Okay, and for Colorado sunken pan, it's 0.78, and for USGS floating pan, it's 0.80. Okay, I would like to stop here for the first part of the lecture. Okay, I will continue with the next part in the next video.